So with that, I'd like to welcome up our first panel. First, we'll have Brett Alexander, the Chief Revenue Officer of Firefly, as well as Jacki Cortese from Blue Origin, who both are on our board of directors. Both have been longtime supporters of the organization. And we'd like to have them to the stage here to talk about the future of landing on the moon and the lunar economy and some of the very exciting opportunities that their companies are both working on.
Well, thank you, Brad. It is great to be here. It's great to see all of you. As you mentioned, I'm Brett Alexander. I'm the Chief Revenue Officer of Firefly Aerospace. I'm joined by...
Does this work? Oh. Hi, guys. I'm Jacki Cortese. I'm Senior Director of Civil Space at Blue Origin. And just a fun fact for you guys, this mini panel is super fun for me because Brett actually hired me at Blue Origin 7.5 years ago. So it's just kind of fun to do this with you.
Yeah.
So.
I'm looking forward to it as well. This is really just going to be the two of us talking about the moon and about what's going on there, the cislunar economy, why the moon, those sorts of things. So when we look at the moon today, there's a big focus on going back to the moon, returning humans to the moon, a lot of science payloads going to the moon. That wasn't always the case. 30 years ago, there was an effort to go back to the moon under President Bush 41. That sort of went by the wayside. That came back under Bush 43. It kind of went by the wayside again in favor of asteroids. And now it's been back in the last 6-7 years about going back to the moon. And I happen to be a longtime fan of returning to the moon back when it had only been, I guess, 20 years from when we had been there the first time. And now it's been 50 years. So it's a long-term effort that a lot of folks in the space industry have been trying to push. And so there are two main things going on with returning to the moon today. There's the human spaceflight program to return astronauts to the surface of the moon. Jacki's going to talk about that, representing Blue Origin with the Blue Moon human landing system. But then there's also a science effort about sending science instruments back to the moon, not only to learn things, but to learn how to use the moon for resources and everything for the future. And so I'm going to talk a little bit about that. So with that as an introduction, if we could have the first chart. Yeah. So NASA has a program called CLPS, which is the Commercial Lunar Payload Services Program. There have been I think 9 task orders awarded to different companies, to 3 or 4 or 5 companies, to send science instruments and other payloads to the lunar surface on behalf of NASA. This is a commercial effort. They have described it as multiple shots on goal, meaning not every one of those is planned to succeed or is going to succeed, but developing the capability over time with multiple landers, multiple companies, multiple efforts, with an industry growing and learning how to do this over time, and actually getting real science and real benefit from those missions. We saw the first 2 of those CLPS missions earlier this year. Astrobotic was the first to launch in January on the very first ULA Vulcan launch. Unfortunately, that vehicle was unsuccessful in its landing. But about a month later, Intuitive Machines was the second company to attempt a landing. Their lander, IM-1, I think it was, had a much more successful landing with orbiting the moon, landing on the moon, slightly tipping over at the last second, but landing on the moon and operating for a while on the moon. And so that was considered a success from a NASA and from a program perspective. The third lander that's going to be going to the moon is Blue Ghost Mission 1. So Blue Ghost is the lunar lander that Firefly Aerospace has developed. We have 2 NASA task orders under the CLPS program, actually 3, but 2 of them are for landers. One is for an in-orbit adjunct to the second mission there. But what you see here is the actual Blue Ghost lunar lander. I think that photo was taken just a couple of weeks ago in our clean room down in Austin, Texas. It will be there for another month or so, and then it's going to shift to an environmental test facility, I believe at JPL, prior to going to the launch site and then launching in the November-December timeframe to the moon. It'll take about 30 days to get to the moon, and then we hope to be the first to have a fully successful upright landing, soft landing on the moon, and operate for a full 14-day lunar cycle, or about 10 of those 14 days. So it will be going to the near side of the moon. So you see up there where it'll be going in the upper right quadrant, I guess, or hemisphere, or however you want to describe it. But it will have continuous line of sight. Our second mission, which will launch about a year later, if you go to the next chart real fast, is going to the far side of the moon, and it will have a payload that is for radio astronomy from the very dark, radio dark side of the moon, to look out and look for signs of life elsewhere in the universe. So that's a very exciting mission as well. Because it's on the far side of the moon, it does need a radio relay, communications relay, and you see that we will be delivering both a European Space Agency payload that is a lunar communications relay, but then also the Elytra Dark spacecraft that we have that will go along with the lander will also function as a relay as well, and deploy other payloads as well. So with that, I want to turn it over. That's the science side. That's where Firefly Aerospace is very excited to participate. And I want to turn it over to Jacki and talk about the human spaceflight side.
Sure, thanks, Brett. If you go to the first chart. So at Blue Origin, our major sort of motto is building a road to space for the benefit of Earth. So a key component of what we're doing is building the transportation systems to enable launch of heavy industry into the space environment. We have a lot of really cool programs I could talk to you about, but I'm just going to focus on Lunar right now because Lunar is a big part of not just developing the infrastructure to open up economic potential in cislunar space, but it's also a big part of the second part of our mission, which is utilizing in-space resources to benefit Earth. So talking about the moon today really hits at those core components of the mission at Blue Origin. We also we have a lot of mottos, I'm now realizing as I'm talking. Another one of them, and you'll see it on the floor of our buildings, please come tour sometime, you guys can talk to me, is Gradatum Ferociter, step by step ferociously. You want to be very intentional, not rush things in spaceflight, especially human spaceflight. So what you see here on this first chart is the first steps of our path to flying humans to the moon for NASA. So on the left side of the screen, you see a mock-up of our Pathfinder lunar lander that's flying to the moon next year, which is very exciting, completely privately funded. That lander is going to test all the core components years in advance of ever flying a person to the moon, right? We're doing a really intentional test campaign, and that Blue Moon smaller variant is a really key part of that. On the top right is a vehicle that hopefully you're familiar with. We fly all the time. It's our New Shepard suborbital tourism vehicle. That picture is important because what that represents is a completely vertical landing with a hydrogen engine, which is exactly what we're planning to do on the lunar surface. And then in the bottom right corner, what you're seeing is our BE-7 hydrogen lunar lander engine, and you'll see through everything that we're doing, a very intentional use of hydrogen toward that utilization of in-space resources, which we'll talk about in a second. If you go to the next chart, thank you. This is our Blue Moon Mark II lunar lander that we're building for NASA to fly 2 astronauts to the lunar surface for the Artemis 5 campaign. One amazing thing about what NASA's doing with Artemis, inclusive of CLIPS, is again this really intentional path to sustainability of deep space exploration. So both Blue and SpaceX's solutions to fly humans to the moon are very long-term focused. You know, things like refueling and cryocooling, maintaining cryogenic propellants at really low temperatures, all these things are hard, and no one's saying that they're not difficult. But the cool and amazing thing about these public-private partnerships is that we're co-investing to tackle these super hard problems to allow for future sustainability, lower cost of deep space exploration. So this is the Blue Moon Mark II with some astronauts for scale. One really interesting thing I think about this lander that you'll probably see is that step-out access to the lunar surface. So the crew will safely touch down under those BE-7 engines and simply descend a couple stairs to access the lunar surface with Blue Moon. So we're really honored to be working with NASA. It's been an amazing partnership. And like Brett said, this really awesome spectrum of lunar transportation that's being developed in US industry with NASA. And then the last chart I just want to quickly talk about is that sustainability aspect. If we can go to the next one. Thank you. And this is a solar panel developed from lunar Regulus simulant. So when you have astronauts on the lunar surface, you want to essentially have them have a lot of the things they need already there, or utilize resources already on the moon, so that we're not carrying so much from Earth, which is obviously a massive expense. It's complexity. It's all those things you don't need. So another thing we're working on with NASA is called Blue Alchemist, and we're essentially simulating what it would be like to use moon dust that's everywhere on the moon, easily accessible, and using some really cool chemical processes that I'll get you the right people if you have detailed questions about it. We have amazing experts in our space resources group, but they're converting this lunar regolith into usable products like solar panels for power. And then ultimately, when you mature these processes for leveraging space resources, you can use the stores of water ice on the moon to create propellants like hydrogen. So this is just the intentionality of what we're flowing through our lunar products at Blue. So that's all I had. That was a lot.
That was fantastic. That was great. I think we're going to ask each other one or two questions to start the dialogue, and then we're going to open it up to you guys until we get kicked off the stage by a more important visitor
Yes, someone
who
much
will be
more
next
important.
on the agenda. So whenever they show up, we'll stop taking questions. But why don't you start?
Yeah, well, I think so, Brett. We dove into a lot of specifics on products and programs, but I think at a high level, you mentioned that you've been a lunar tick for a long time. So what about the moon? Why the moon? Why is there so much focus on it? Why are you such a believer?
Yeah, that's a great question. And I really think that the subtext is that for at least my 30 years in this business, there's been an ongoing debate about the moon versus Mars. And you see that quite a lot now, but it's really been there all along. There are folks that said we went to the moon, we had flags and footprints, we've done that, been there, done that. I think President Obama said that. But the been there, done that crowd that says now we need to move on to Mars or at least do something different. Getting to Mars is exponentially harder than getting back to the moon. It's probably not, if you do the math from a physics standpoint and a mass of equipment you need and the timeline, it's not 10 times harder, it's 100 to 1,000 times harder. And the simple fact is we haven't been to the moon in 50 years. The things that we did to get there, we have none of those anymore. We don't have the Apollo program, the Saturn V launch vehicle. We don't have the lunar module. We don't have that same infrastructure that we did then. Plus, the only reason, one of the things I like to say about getting to the moon is, back then is the reason we could get to the moon is because we didn't have a million lines of code and all that software. Because every time you launch something into space, you find all the problems that are software driven. Whereas with Apollo, it was very, very simple technology, very, very simple from a computer standpoint, and they were able to exercise that quite a bit. Very successful program back then, but how do we go forward now? And so the moon versus Mars really, there's two things about the moon. One is it's there, it's close, it's a 3-day journey away. And so if you're going to practice, if you're going to get good at something, you want to do it more than once. You want to practice it over and over and get really good at it. You want to do that 3 days away, not 180 days away, or however long it would take you to get to Mars and back. So that's one thing. And the second thing is really about resources. How do you use in situ resources to minimize the amount of hardware that you need to take, propellants that you need to take, logistics that you need to take to eventually go on to Mars? So if you can develop an ecosystem with the moon where you can use those resources and you can develop the technologies and the systems and the capabilities to really have a felicity with sending people to and from another body, that is absolutely going to make it easier to go to Mars. And so if in my sense, or my way of thinking, if we want Mars in my lifetime, we really have to go through the moon in order to get there. One other thing that I think we should talk about, and we could talk more about it, is what underlying both of these efforts, the human landing efforts under Artemis and the commercial landing, or the CLIPS program, is really that commercial partnership that you were talking about. It's NASA in an era of fixed budgets where it's not the same sort of focus as it was during the Apollo timeframe. It's NASA leveraging both international but mostly commercial capabilities and resources and funding, and developing an ecosystem around that so it's not the only one paying for it and sustaining it. Because as we saw before, that is not sustainable. And if we want to sustain human activity in space beyond Earth, that's going to be an incredibly important thing. And so from a Moon versus Mars perspective, the commercial activities are going to flourish at the Moon, whereas it would be quite a struggle to get them to flourish out at Mars. So.
Yeah. That was very thorough. Thank you, Brett. And I think, I completely agree on the partnership aspect. Everything I showed you all in our charts from our BE-7 engine, we've worked on with NASA Marshall in Huntsville for many, many years, a long time, to the solar cell project that we're working on with Space Technology Mission Directorate and the Human Landing System with the Exploration Systems Directorate. Everything we're doing is in partnership, and it's been, you go a lot farther like that. So like Brett and I mentioned, our much more important speaker is here in the back.
Right.
So we'll quickly take one question from the audience.
Okay.
Go ahead.
All right, it's you.
You mentioned how CLIPS was an important part of your current activities. I was wondering, have you had thoughts about whether CLIPS can be replicated for other planetary bodies, such as for Mars, or potentially even replacements for Discovery and New Frontiers class missions?
Sorry, Aaron, introduce yourself.
Sorry. My name's Aaron Zuckerman. I'm a Matthew Isaacowicz Fellow and a former Future Space Leaders Fellow.
Great. Well, thanks for the question. Absolutely, the CLIPS model can be replicated. At its heart, it's a commercial, public-private partnership effort where NASA is an anchor tenant for missions with science instruments, et cetera. That commercial public-private partnership model with NASA has worked on commercial cargo to the space station, commercial crew to the space station. We see it now with CLIPS, and we see it with the Human Landing System program. So to extend that to other planetary landings and orbitings and other science activities, as long as there's a commercial rationale for the technologies, if not necessarily the destination or the objective of the mission, as long as the commercial rationale exists for those capabilities, you will get commercial companies to invest in that public-private partnership. So that's been a very successful model for NASA. I give them a lot of credit. That's been a 18-year push since 2006 with the original COTS program. And so that's been quite successful. So I think the CLIPS model can definitely be replicated. Anything to add to that?
No, I was just going to say I completely agree with Brett. I think it can be. And I think some cool things that are happening is that NASA's continuing to realize how much investment is going on in industry into new capabilities. So for example, like you mentioned Elytra. And we have Blue Ring. So some of these new multi-orbit transfer type vehicles are enabling a lot of new commercial opportunities at other planetary bodies. And NASA's leaned forward with studies and a bunch of new projects. So I think these things, first you study it, then you do it, right? And so I think the agency is amazing at recognizing these opportunities because industry is continuing to invest on its own, and taking advantage of those products is definitely in the roadmap. So I think CLIPS, or the theory of CLIPS, can absolutely be replicated, especially with some of the private industry investment that's continuing to go on. So yeah.
All right, well,
thank you.
Let's just say thank you, and I'm going to turn it back to Brad to introduce our next speaker. So
thanks, guys.
Thank you all.
Thank you so much, Brett and Jackie. What a great conversation. And if you look at our schedule, most of our programming today we have labeled as Camp Fireside Chats. They may seem like a strange thing to talk about when it's 110 degrees outside. But I want to assure you that in Colorado, where I live, in the mountains today, the high is in like the 70s, 20% humidity, and the low last night was about 50. So we're thinking campfires, and the nighttime here, I think the low last night was 75, maybe not quite campfire weather. So I didn't know about the weather when we named the panel, so give me a little stretch there, please.